Kia ora, Year 11. This is the second video going through the 2024 WC Year 11 exam. This one's going to be a little bit faster than the last one, but it is going to focus on algebra and graphing stuff, just like the first one did. Remember, have your book and pen out with you ready to try the questions as you go, and use your I Can Do sheet to figure out which Dr. Frost skill and teaching video goes with each question, okay? Because I'm going to go reasonably fast in here. All right, so the first question that we're going to look at is a rearranging one. We have to write T in terms of R and S for this formula here. So we've got R as the subject at the moment. And we have to rearrange to make T the subject. So let's just have a look. I'll find a new page. Okay, so we're starting off with R is equal to S cubed T squared divided by 4. Now it's good just to do one change at a time, so one per line. The first thing I'm doing is I'm timesing both sides by 4, so I get 4R is equal to S cubed T squared. The next thing to do is to divide both sides by S cubed, because remember my goal is to get T on its own in here. So we're going to have 4R over S cubed is equal to T squared. If you want to, you can write it the other way around. It doesn't make any difference, but it's nice to end up with T equals, but we don't have to. So T squared is equal to 4R divided by S cubed. Now this is the only bit where you have to kind of use your brain a bit more, is when we undo a square, we're going to square root. So we get T is equal to the square root of 4R divided by S cubed, because square rooting is the inverse operation of squaring. But we don't know if the number that resulted in this thing here was a positive or a negative number. So that's why usually when we take the square root, we're going to have to say we want either the negative of that number or we just want the positive version, okay? So let's just go over that one more time. If I write the square root of 9, that means 3. Okay, if I want to generate negative 3, I have to say negative root 9. So negative root 9 is negative 3. So if we see, for example, that T squared is equal to 9, then T is equal to plus or minus the square root of 9. So that's what we're doing in that question. Okay, so I said I was just going to do revision and not teach, but so sorry for that little bit of sidetracking. So my final answer for this question needs to be T is equal to plus or minus the square root of 4R over S cubed. Let's go back to these questions. Let me find the right slide. Oh, that's the wrong one. Where's it gone? Okay. Here we go. Now the next one is a word problem, which is simultaneous equations. These look daunting, but once you've defined what the variables are, they usually fall out quite well. So if we just read it through, the cost for 4 adults and 2 children on the Inter-Islander is $262, and the cost for 2 adults and 3 children is $197. We have to calculate the cost for 1 adult and the cost for 1 child. So I'm going to start off by just defining my variables, and I'm going to write let the adult price be A, and then let the child price be C. So we were told that 4 adults and 2 kids cost $262. So we can say 4 adult tickets plus 2 child tickets is 262, 2 adult tickets and 3 child tickets is 197. So looking at that, we have our 2 main methods to solve simultaneous equations. We have elimination and we have substitution. Elimination is where we have all the columns lined up nicely, and that's the one that I'm going to use here that we've practiced heaps and heaps in class. So looking here, we're trying to match up one of these terms. You can see here that we've got 4A here and we've got 2A here. So if I double everything here, I'm going to have a match on the 4A. So we're just going to leave that first equation. 4A plus 2C is equal to 262, and we're going to times this one by 2 on both sides. So 4A plus 6C is equal to 2 times 197, which gives me 394. Right, remember the idea here is that if 2A plus 3C is equal to this, then if I times this by 2 and this by 2, nothing has changed. Now the reason that we like doing that is that if we label this one equation 2 and this one equation 1, then I can say, well, if I subtract everything in equation 1 from equation 2, I've got 4a take away 4a, leaves me with nothing. 6c take away 2c leaves me with 4c. And $394 minus $262 leaves me with $132. That lets me find the child cost easily by dividing by 4. So I get c is equal to 33. And we're going to whack in a dollar sign for that. Right, now I still need to write that in context, but that's the first part done. The next thing we have to find is the adult ticket price. So I can put this into any of these equations. I'm going to go back to the first one. So I'm going to use this information in this equation. And I get 4a plus 2 times 33, 66 is equal to 262. That gives me 4a is equal to 196. So dividing by 4, I get 49, and that's $49. Right, so the adult price is 49 for one adult, and the child price for a ticket is 33. Okay, let's see what's next. So the next one is a simplifying one. Now, when you see these in exams, they're often easier than when we have to factorize quadratics kind of in the wild. What we're looking at here is a quadratic in the numerator and a quadratic in the denominator. So my strategy is usually to start with factorizing the easy one and then kind of hope that you can see a common factor coming. That's going to be faster than using the grouping method, and that works quite well in this example. So I'll just move down here. So let's write out what we've got. We've got 3x squared minus 19x minus 14 divided by x squared minus 11x plus 28. Factorizing the denominator is a year 10 level quadratic. Pattern is x here and x here. We've got two numbers that times to 28, and I've got to take away 11x here. So it's going to be a minus minus pattern, and 7 and 4 will work. Now I quite like that because when I look at my numerator, I can see that I've got a minus 14 here, and I've got a 3x here. So let's just give it a go, and if we have to stop and do grouping, we will. But we'll try it like this first. So 3x here and x here. Now, I've got an x minus 7 factor here. If I want something to cancel out in here, it's not going to be the x minus 4. It's going to be the x minus 7. So we'll try putting x minus 7 there. We can see that we get 3x squared here. To generate the minus 14, I'm going to have a plus 2 here. So let's check if it works. We've got 3x squared plus 2x minus 21x. So plus 2 minus 21 does give me negative 19x. So that's great. So we're done. Except we haven't finished simplifying because now we have a lovely common factor in the numerator and the denominator. So we're going to divide through by x minus 7. And my final answer is going to be 3x plus 2 over x minus 4. Very good. Right, where are we up to? I think we're up to the graphing ones. Yeah, we are. Right, so next we've got two questions about quadratic graphs. The first one is a pretty easy find the equation of the graph. But when I say it's easy if you know how to use the three patterns of quadratic. So that's expanded form, factorized form or roots form, and vertex form. So if you're confident with those and with checking for a scale factor, this problem's not bad at all. And then we have to do some transformation stuff. So let's have a look at the graph first. We have to find the equation of the graph. And you can see from the information structure that vertex form is going to be the way to go. We know the vertex is at a nice round 3, 3 coordinate. And we've also got the y-intercept. You can see also that you don't have lovely integer values for your roots. So we don't want to use factorized form, and we never really want to use expanded form for finding the equation unless we're kind of desperate. So using vertex form, I can write down, let's just erase this and get some space back. So the vertex is at 3, 3. So the equation is going to be this. It's going to be y is equal to k times x minus 3 squared plus 3. And we know from looking that this is an upside down parabola, so k is going to turn out to be a negative number. The next thing we're going to do is substitute in a point, and that point is 0, -6. So we get -6 is equal to k times 0 minus 3 squared plus 3. So what we're doing now, remember, is we're trying to find the scale factor. We've got the basic shape, we've got the basic pattern of the quadratic worked out. -6 is equal to 9k plus 3. -9 is equal to 9k. So k is equal to -1. That means that my equation, so we need to put this back in here and finish it off. So y is equal to negative x minus 3 squared plus 3. And it's fine to leave it like that, or we could expand it out if we wanted to. We don't have to do that for this question, but it's good practice. So let's just have a look at how we do that. So y is equal to negative we've got a perfect square here, so we've got minus x squared minus 6x plus 9 plus 3. Now I'm going pretty slowly with this because it's very easy to make mistakes with negative signs here. So I want to do this just to show you the link up with expanded form and that y-intercept. You can see that when we've written it in expanded form, we can see the upside down parabola, and we can see that -6 on the end, which is matching up with my graph here. Right, so just one last thing to say to you in case you have a freak out about how to find the scale factor. In this example, I'll just get rid of the working here. In class, we've looked a lot at a basic pattern of a parabola going out 1, up 1, out 1, up 3. And you could have used that here if you were not comfortable with using algebra. So here we've gone out 1, and then we've gone down 1. Out 1, we're at 2, down 3. Oh, what a mess. Never mind. So we've got 1 here, 1 here. So it's out 1, down 1, out 1, down 3. And then when we do that again, out 1, and it's down 5. So that's my standard pattern with no scale factor. So you didn't actually have to use algebra to find the scale factor here. All right, now the last part of the question is the harder bit where we look at our transformations, and we're told to shift the graph down. So if the graph has been shifted 2 units down and reflected on the y-axis, what's the formula of the new graph after this transformation? So let's do it in steps. We're starting out with y is equal to negative x minus 3 squared plus 3. So that was the equation we found up above. Remember that to do a vertical shift with any function is very easy. We've got plus 3 on the end already. And to move it up or down, we're just going to put a plus or a minus something on the end again. So to move it 2 units down, we take what we started with and we move it down 2 like that. So that gets me the new equation of it shifted down. So we've got this. Now, if we want to reflect anything in the x-axis, suppose that we had a line up here like this. If we want the mirror image, I can't draw upside down. Anyway, it's down here like this. So to shift this to this, we have the new y is equal to the negative of the old y. So that makes doing reflections in the x-axis also really easy once you spot that. So our new y is going to be the negative of the old y, which is this one here. And that gives me x minus 3 squared minus 1. Okay, so I was going to try and do a GeoGebra graph of that, but I realized that I'm going to run out of recording time because I've only got 15 minutes. But that's your basic process for doing a reflection in the x-axis. Okay, so the new y is the negative of the old y. Thanks for watching. I'll do some of the geometry questions later on today.